what are the what are the consequences of lanthanide contraction? What are the consequences of lanthanide contraction? This is a question we will see now. The answer goes like this. Very important. Due to lanthanide contraction, due to లాంథనాయిడ్ అని అంటారు, కొన్నిసార్లు లాంథనైడ్ అని కూడా అంటారు. Lanthanide, lanthanoid, sometimes lanthanide. I have seen both the things in books. So, ఈ రెండు ఫాలో అవ్వచ్చు మీరు. Lanthanide contraction. The crystal structure, and other properties of lanthanides are similar and they are difficult to separate, and they are difficult to separate, lanthanide contraction. So because దీనికి ఇంకొక రీజన్ ఏంటంటే, because of this lanthanide contraction, we get the ions of same size which exhibit same properties. I should say similar properties. Which exhibit similar properties. Lanthanide contraction is also observed in 5D elements. Lanthanide contraction is due to poor shielding of f orbitals. అదే మనం చెప్పుకుందాం. Because of f orbitals, they shield very poor, the size of the ions will start reducing. So because of that, what happens is we'll get same size ions. If ions are of same size, they will have same properties. That is one problem you get the same size ions, they will show similar properties. So if they show similar properties, it is very difficult to separate them chemically. Similar, that is a problem in chemistry. Similar size ions, very difficult to separate. Very difficult to separate. This is a problem with chemistry. Okay, same kind of chemistry, the reactivity is same, chemistry is same type of chemistry. Hello, 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 some doubt someone is having? Hello, someone is having some
Nothing,
doubt?
sir.
Okay, okay, right, fine. So they have same kind of chemistry. If you have similar kind of ions, they have same kind of chemistry, so it is very difficult to separate. Okay, that is the problem. Okay, so can I clear this one? Okay, hope I can clear. Now, the sizes of the sizes of 4D and 5D elements, 4D and 5D elements, the sizes of 4D and 5D elements in a group are almost similar, are almost similar. Hardness, melting point, melting point, and boiling point, and boiling point of lanthanides, increases from cerium to lutetium due to lanthanide contraction. Due to lanthanide contraction. Written clear?
Clear, sir.
Okay, fine. Now, this is a separate thing. What is a cation? Cation means positive ion. Okay. It is formed by the removal of electron from any atom. Okay. So what is a cation? Cation means a positive ion. It is formed by removal of an electron from any atom. For example, K means potassium. From potassium, if I remove electron, I will get potassium plus electron. Okay. Similarly, from sodium, if I remove an electron, I will get sodium plus electron. Okay, like this. This is how we get a cation. Radius of cation. Radius of cation is always less than that of the radius of an atom. Radius of parent atom. Clear? So what is a cation in chemistry? Cation means positive ion. It is formed by the removal of electron from a atom, from any atom. If you take any atom and then remove an electron from it, you get a cation. Clear?
Yes, sir.
Clear, sir.
Very good, very good. Now, next point. What is an anion? Anion means it is a negative ion. Negative ion. It is formed by adding electron to any atom. Okay. So here we go. Suppose manaki chlorine anukundam. Chlorine atom. Chlorine atom. Atom of chlorine. Chlorine atom plus electron. If I give an electron to chlorine atom, I will get Cl minus ion. This is anion. Similarly, hydrogen atom plus electron, we will get H minus ion. So these are examples. Okay. Radius of anion is always greater than that of parent atom. Parent atom is always greater than that of parent atom.
Clear, sir.
Next one. Next, we talk about a different concept called isoelectronic species. What are isoelectronic species? Or the group of atoms or molecules having, okay, I can say the set of group of atoms or molecules having same number of electrons, same number of electrons are called isoelectronic species. Isoelectronic species. I'll give an example. For example, we can consider carbon monoxide and nitrogen, N2. Why? Carbon monoxide, in the carbon monoxide, carbon is having atomic number 6 kada. 6 is for carbon and 8 is for oxygen. Total 14 electrons. Okay. Similarly, nitrogen, if you consider, nitrogen is atomic number 7, that is 7 electrons are there, 2 nitrogens are there, 7 into 2, 14 electrons. Okay. So that's how I can say that these two are isoelectronic. They both these species, this group of atoms and this group of atoms, they have same number of electrons. They have same number of electrons. They are isoelectronic. They are isoelectronic in nature. So here among the isoelectronic groups, among the isoelectronic groups, radius decreases. Radius decreases. Radius decreases. Radius decreases with increase in the nuclear charge. With increase in the nuclear charge. Nuclear charge. See, if the nuclear charge increases, the nuclear charge will plunge the electrons towards the center, so the radius will decrease. Written, clear.
Clear, sir.
Yes, sir.
So isoelectronic species. This is a very important thing. Next, what is ionization potential What is ionization potential or ionization energy? Or ionization energy. What is ionization potential or ionization energy? Energy required, energy required, energy required to separate, energy required to separate the outermost electron, the outermost electrons, energy required to separate the outermost electron of a isolated metal atom, of a isolated metal atom, or metal atom, or you can say any kind of atom. Okay, it need not be metal only. Generally the metal atoms will give out electrons, so that's why they consider metal atoms. Metal atoms have a tendency to lose electrons. That's the reason they have written metal atoms have tendency to lose electrons to form positive ions. Positive ions. This is one important point you had to know. Or any atom, you can take any atom. Okay, is called ionization potential. Is called ionization potential or ionization energy. ఇక్కడ ఇంకో పాయింట్ యాడ్ చేద్దాం. Hence they are said to be electropositive. They are said to be electropositive. Electropositive. Metals are electropositive. To say that because they have tendency to lose electrons, metals are said to be electropositive.
Clear, sir.
Clear? Fine, good. Next we move on. Ionization potentials. IP అంటాం ఇంకా నుంచి. Ionization potentials are determined by discharge tube experiments. By discharge tube experiments. By discharge tube experiments, units of ionization potential. This is also very important. It is electron volt per atom or kilojoule mole inverse. These are the units. 1 electron volt per atom is equal to 23.06 kilocalorie mole inverse. Similarly, that is also equal to 96.45 kilojoule mole inverse. These conversion factors you have to remember. Written.
Yes, sir.
Yeah. Next one. On what factors does ionization potential depend upon? On what factors this ionization potential will depend upon? Ionization potential values are dependent upon atomic radius, nuclear charge, atomic radius, nuclear charge, screening effect, penetration ability, of orbitals, and electronic configuration. These are the factors on which ionization potential values will depend. I will add a point. Elements having completely filled or half filled configuration or half filled configuration completely filled or half filled configurations are more stable or more stable and need more energy for ionization and need more energy for ionization and need more energy for ionization.
Clear, sir.
Clear. Good. Next. In a group, the ionization energy or ionization potential ఏదైనా చెప్పొచ్చు, we can say anything, okay, decreases down the group, decreases as we as we go down the group, as we go down the group, as the size and screening effect size and screening effect increases. So what is this? ఇది కొంచెం explain చేద్దాం. So we'll consider the first group elements: hydrogen, lithium, sodium, potassium, rubidium, cesium. Of course, the next element radioactive, don't worry about that. Up to cesium we'll see. Down the group movement means it is like this downwards you have to move. Now when you move down, the atomic number increases. Atomic number will increase. There is something called, they are telling, screening effect. What is this screening is? Suppose this nucleus is there, nucleus is positive charge. As atomic number increases, the positive charge increases. Please understand, atomic number increases means number of protons in the nucleus will also increase. Atomic number increases, number of positive charge, that is protons in nucleus increases. Nucleus increases. Most important. So when this increases, the force of attraction between the nucleus and electron increases. Okay, na? So here, what happens is, in the case of screening, some orbitals will be there, like s orbital, which I discussed earlier. S orbital, all these things, they have the electrons, right? These electrons will shield the positive charge, will not allow the electric lines of force to pass through them. So because of that, the last shell electrons will not feel that much amount of force. The last shell electrons will not feel that much amount of force. Because they don't feel that much amount of force, the electrons are added to the new shell. Electrons are added to the new shell. As we go down the group, electrons are added to new shell as we move down the group. Go down the group. And that electrons are not feeling that much amount of attraction. So the reason, the size of the atom will increase. So this is the most important. And this stopping of this electric field lines is called screening. The electric field lines will be stopped by some of the inner electrons. That is called screening. Clear? Electric field lines are stopped by some inner electrons. You can make a note. Electric field lines are stopped by some inner electrons of the atom. That is called screening. Electric field lines are stopped by some, anyway, I'll clear and write. Electric field lines are stopped by electric field lines from nucleus. Okay, from nucleus are stopped by the inner electrons